color code for insulated terminals, specifically red for number 22 to 18 AWG, blue for number 16 to 14 AWG, and yellow for number 12 to 10 AWG, is not a national electrical code or NEC standard. It's a widespread industry practice embraced by numerous electrical manufacturers. The primary aim of this color code is to assist electricians in quickly identifying the size of the wire they are working with. These colors are assigned according to the American wire gauge, or AUG, system, which serves as a standard for measuring wire diameter. A higher AWG number signifies a smaller wire diameter. While the color code isn't legally mandated, it's extensively used throughout the electrical industry because it enables electricians to swiftly determine the wire size, reducing the potential for errors. Here is a summary of the color code. Red typically indicates number 22 to 18 AWG wire. Blue generally signifies number 16 to 14 AWG wire. Yellow usually represents number 12 to 10 AWG wire. However, it's important to consider some additional information. Firstly, a color code isn't always consistent across different manufacturers. Some manufacturers might use different colors for the same AWG sizes. Secondly, the color code isn't universally applied to all types of wire. For example, it's not commonly used for stranded wire. Thirdly, the color code isn't a replacement for accurate wire sizing. Electricians must always select the appropriate wire size for the specific application. Therefore, reliance solely on color codes without verifying wire gauge through other means could lead to unsafe installations. The NEC, although it doesn't specify terminal color codes, does provide comprehensive tables and guidelines for appropriate wire sizing based on ampacity, voltage drop, and application. Consulting these tables is critical for ensuring safe and code-compliant electrical work. The industry practice of using color codes for terminals arises from a need for quick visual identification in the field. Imagine an electrician working in a panel with dozens of wires. Quickly spotting the color of the terminal allows them to get an idea of the wire size connected to the terminal without having to closely examine the wire markings in every case. This saves time and reduces the chance of error, especially in poorly lit or cramped environments. However, this quick visual check should always be followed by a more thorough verification of the wire gauge. Furthermore, it's important to consider the type of insulation used on the wire. While the terminal color code provides an indication of wire size, it doesn't tell you anything about the insulation rating. The insulation must be appropriate for the voltage and temperature conditions of the application. Refer to the NEC for proper insulation types based on the environment where the wiring is installed. The NEC also provides guidelines on the proper methods for terminating wires. This includes ensuring that the terminal is properly sized for the wire and that the connection is tight and secure. Loose connections can cause arcing, overheating, and even fires. So, while color codes are a helpful tool, proper termination techniques are essential for safety and reliability. Another aspect to consider is the environment in which the electrical system is installed. In corrosive environments, special terminals and connectors may be required to prevent corrosion. Corrosion can lead to increased resistance, voltage drop, and eventual failure of the connection. The NEC has specific requirements for wiring in hazardous locations, such as areas where flammable liquids or gases are present. In these locations, explosion-proof fittings and enclosures are required to prevent ignition of the flammable substances. Therefore, while the color code offers the starting point for wire identification, the overall system design and installation must take into account the specific environmental conditions. The color code for terminals typically applies to insulated terminals. These terminals have a plastic or nylon insulation sleeve that covers the barrel of the terminal. The insulation provides protection against short circuits and helps to prevent accidental contact with live parts. Uninsulated terminals are also available, but they are typically used in applications where the risk of short circuit is low. When working with uninsulated terminals, it is important to take extra precautions to prevent accidental contact with live parts. Always to energize the circuit before working on any electrical equipment. Use insulated tools and wear appropriate personal protective equipment, such as gloves and eye protection. The NEC requires that all electrical work be performed by qualified individuals who are trained in safe electrical practices. This is to ensure that the work is done correctly and that the risk of electrical shock or fire is minimized. If you are not a qualified electrician, do not attempt to perform any electrical work. Hire a qualified electrician to do the work for you. They will have the knowledge and experience to do the work safely and correctly. In summary, the color code for insulated terminals is a helpful industry practice, but it is not a substitute for proper wire sizing and termination techniques. Always refer to the NEC for specific requirements and guidelines. Hire a qualified electrician to perform any electrical work. This color coding system allows for easier identification during installation and maintenance. However, it's critical to note that the absence of a specific mandate within the NEC doesn't diminish the importance of adhering to recognized industry best practices. Many local jurisdictions and project specifications may incorporate these color codes by reference or through specific requirements. Therefore, electricians should always consult local codes and project documentation to determine if these color codes are required for a particular job. Furthermore, while the color code is primarily associated with insulated terminals, it can also be applied to other types of connectors and splices. In these cases, the color of the connector body or the insulation and the splice indicates the wire size range that the connector or splice is designed to accommodate. Again, it's crucial to verify the connector or splice is properly sized for the wire being used, regardless of the color coding. The AWG system itself is based on a stepped gauge system where each gauge number represents a specific cross-sectional area of the wire. The cross-sectional area determines the wire's ampacity, which is the maximum amount of current that the wire can safely carry. The NEC provides ampacity tables for different wire types and insulation ratings. These tables should be consulted to ensure that the wire is properly sized for the circuit it is serving. Using a wire that is too small for the circuit can lead to overheating, insulation damage, and even fires. Conversely, using a wire that is larger than necessary is generally safe, but it can be more expensive and difficult to work with. The color coding system also extends to other components in the electrical system, such as fuses and circuit breakers. Fuses are color-coded to indicate their ampacity rating. For example, a 15-amp fuse is typically blue, while a 20-amp fuse is typically yellow. Circuit breakers are not typically color-coded, but they are marked with their ampacity rating. It's important to use the correct size fuse or circuit breaker for the circuit being protected. Using a fuse or circuit breaker that is too large can allow excessive current to flow, which can damage equipment and cause fires. In addition to the color coding of terminals and fuses, there are also color codes for wiring itself. In North America, the NEC specifies the following color codes for branch circuit wiring. Black is typically used for hot conductors. White is typically used for neutral conductors. Green or bare copper is typically used for grounding conductors. These color codes are designed to help electricians quickly identify the different conductors in a circuit. However, it's important to note that these color codes are not always followed, especially in older installations. Therefore, it's always important to verify the conductors with a voltage tester before working on any electrical circuit. The NEC also addresses the use of identification means for conductors larger than number 6 AWG. These conductors must be marked with their size, voltage rating, and insulation type. The markings must be visible after installation. This is to ensure that electricians can easily identify the conductors and verify that they are properly sized for the circuit. In conclusion, the electrical industry uses a variety of color codes to help electricians quickly identify different components and conductors. While these color codes are not always mandatory, they are widely used and can be a valuable tool for ensuring safe and efficient electrical installations. Always consult the NEC and local codes for specific requirements and guidelines. The value of industry standards such as this color code cannot be understated. These standards enable efficient communication between electricians, manufacturers, and inspectors, leading to safer and more reliable electrical systems. Moreover, adherence to these color codes reduces the risk of miswiring, which can have serious consequences. The use of color coding also facilitates troubleshooting. When problems arise, electricians can use the color codes to quickly identify the different conductors and components in the circuit, making it easier to diagnose the issue. Furthermore, the color coding system aids in the training of new electricians. By learning the color codes, they can quickly grasp the basics of electrical wiring and safely perform their jobs. It is important to emphasize that electrical work can be dangerous if not performed properly. Therefore, it is always advisable to hire a qualified electrician to do the work for you. A qualified electrician has the knowledge, skills, and experience to do the work safely and correctly. Before hiring an electrician, be sure to check their credentials and references. Ask them about their experience and qualifications. Make sure they are licensed and insured. The NEC is constantly evolving to keep pace with new technologies and safety concerns. Therefore, it is important for electricians to stay up to date on the latest changes to the code. This can be done by attending continuing education courses and reading industry publications. In addition to the NEC, there are also other standards and guidelines that electricians should be aware of. These include standards from organizations such as the Institute of Electrical and Electronics Engineers or IEE, the National Fire Protection Association or NFPA, and the Underwriters Laboratories or UL. These standards cover a wide range of topics, including electrical safety, equipment performance, and installation practices. In summary, the electrical industry relies on a combination of codes, standards, and industry practices to ensure safe and reliable electrical installations. The color code for insulated terminals is just one example of how these practices can help electricians quickly and accurately identify different components and conductors. However, it is important to remember that these practices are not a substitute for proper training and knowledge. Always consult the NEC and other relevant standards before performing any electrical work. And if you are not a qualified electrician, hire one to do the work for you. Ultimately, understanding and adhering to these industry practices promotes safety and efficiency in electrical work. This, in turn, leads to better outcomes for both electricians and the end users of electrical systems.